Okay, so guys, we had a homework yesterday, so I remember. Okay, just a moment. Okay, so I remember giving you a question like this. Suppose you have two routers, okay, and suppose you got two switches here, and the task was to obtain the telnet and SSH of this switch 1, say router 1 or router 2 and switch 2 from these computers, right? Okay, so you have got it, right? So now how did you get it? So you have given the telnet or the SSH, say the configurations there. So you have created the username, you have enabled the telnet or SSH. Okay, now say you can SSH to this switch, then again SSH to this one, then to this one, then to this one. That is what you have done, right? Yeah. Everyone done? Yes. Now let me tell you, now that I do not want you guys to do it like that. Okay, I want from this computer itself, I need to directly telnet here. You didn't get. Okay, yes, there. Destination host unreachable. Okay, find out how you can do it. That's the task for today. Okay, clear? Find out how you can do. So here you have a computer. Okay, from this computer you need to directly telnet or SSH to this switch. Go with the packet flow, you will understand. Okay, go with the packet flow and you won't be able to do it, but still say need the answer. What is the issue? Okay, everyone? Okay, yes. So that's good news, guys. You have started doing the homeworks, right?
I always do.
You always do. Okay, so then I'll always give the homeworks, no worries. Okay, you always do the homeworks, right? Okay, so now today we'll be going with spanning tree. Okay, spanning tree, we have already discussed the theory yesterday. Now that, let me show it to you. Okay, so I told you that by default spanning tree will be working. Okay, you don't have to do anything. Okay, suppose I'm taking 3 switches. Okay, switch 1, so let me expand it. Suppose this is switch 1. Okay, S1. Okay, and suppose this is switch 2. S2. Okay, and suppose this is S3. Okay, now, yes guys? Okay, now, I remember connecting, yesterday we have connected it like this. If I am not wrong, I may have connected from F0/1 to F0/2, and again F0/1 to F0/2, and again F0/1 to F0/2. Okay, now, so here I suppose, okay, this S2 might be the root switch. So let me again rename it. Okay, let me just rename. Suppose this is S1. Okay, I'm just going with yesterday's topology. Okay, so duplicate. Okay, so let me, so this is S2. Oh, okay, so this is S2, and suppose this is S3 and this is S1. Okay, so now they have found out the root switch, and they have say come up with the root switch, and then they have come up with the, they have already done it. Okay, they have already found out the root port, the designated port, and you can see this interface is now orange or amber color, and this has gone to the blocking state. This has gone to the blocking state, while others are the in the forwarding state. Okay, so suppose S1 is the root switch. S1 is the root switch. So by default, the priority will be 32,768 for everyone. Okay, then the root switch will be selected based on the MAC address. The switch with the least MAC address will be having the root switch will be the root switch. Okay, so now let me take S1, okay, and let me execute the command show spanning -tree. This is the command, show spanning -tree. So if you execute this command, you can see it shows spanning tree enabled protocol IEEE. Okay, now a root ID, so it shows the root ID or the root switch ID. Okay, so the priority is 32,769 here. I told you the priority is by default it's 32,768, but you can see something one here. This one is the system ID extension. It's the system ID extension which will get added to the priority, which is, and hence you got the priority 32,769. Clear? And you can see this, the address, the MAC address of the root switch 0007 4D-BC. That's the root switch MAC address, and this bridge is the root. So S1, we are in the S1, and S1 itself is the root switch. Okay, now you can see the timers: hello time, maximum is time, forward delay time, etc., and the bridge ID. So this is the local switch bridge ID. Okay, so now that both this switch itself is the root switch, root ID and bridge ID both will be same. Okay, so here you can see the priority is still 32,769 and the address here, the MAC address are same. Now hello timer, these are the timers here, and yesterday I told you, so this is the root switch, and so all the interface of the root switch will be designated port. All the interface of the root switch will be designated. So F0/1 and 0/2 both are designated port, and so both are in forwarding state. Clear? Okay. Now considering this switch S3, okay, so S3, so suppose yesterday I might have told you that S2 was having least switch ID. S2 was having least switch ID. Okay, and so this port might have become the designated and this might have become the blocked. Okay, now here in this case it is the reverse. Okay, so S3 being, say, with least switch ID, this will become the F0/1 will become the designated and F0/2 will become the root. Shall we check it?
Yes.
Okay, so again the same command, we'll go to the switch, show spanning -tree. Okay, so you can see F0/1 has become the designated port and F0/2 has become the root port, and so both are in the forwarding state. Clear? Okay. Now here F0/2 is blocked. Let me show it to you. Okay, show spanning -tree. So you can see F0/2 is in block state. Any doubts? Okay, so this is how the spanning tree works. Okay, so now this is the root switch. Okay, now so here the path, so port cost is 19, here the port cost is 19, here the port cost is 19. Okay, so now let me ask you a question. Or suppose if I change the path cost, so suppose here this is 19, 19 and 19, both are root port. Okay, this is root port and this is root port. Now I will customize this topology. So today we are going to talk about customization, spanning tree customization. So if at all I need to make this one F0/1 as the root, F0/1 as the root. So let me change the cost here. The cost, let me change the cost to 40. Let me change the cost to 40. If I change the cost to 40, then going via this path, the path cost will be 40. Going via this path, the path cost will be 38. Getting it?
Yes.
Okay, so this path will be selected and F0/1 will become the root port and this will become the designated. It will change to designated port. Clear, guys? Shall we? Okay, so now, so here first let me go to S3 here. To change the port cost, we'll go to that interface. Okay, we'll go to this interface F0/2. Okay, yes? Okay, let me tell you. So here So at present, let me tell you, at present, say both are the designated. Both are designated. Okay, and this is the root port. This is also the root port, and this is the designated port, and this is the blocked port. Okay, so here the path cost is 19, 19 and 19. Now if the path cost, now that I'm changing the path cost to 40, I'm changing the path cost to 40. So what happens is that the superior BPDUs will be received through F0/1 with least path cost of 38. Okay, so here what happens is that this will become the root port. This will become the root port. Now opposite to the root port you have designated port. Okay, so opposite to the root you have designated. So this will become designated. Now let me again tell you, this port which was initially the root port will now is not the designated port nor the root port. Okay, so this will get changed to the blocked one, blocking port. Got it? Okay, so now we shall see that. Okay, so to change that, we'll go to F0/2 and we'll change the priority. Sorry, we'll change the cost. Okay, so we'll go to S3 here and we'll go to F0/2 interface FA0/2 and the command to change. So let me show you, do show span. So now you can see the cost is F0/2, the cost is 90. Okay, and to reach the root switch also the cost is 19. You can see, to reach the root port, the root switch, the cost is 90. Okay, now let me change it. The command to change the cost is spanning -tree VLAN 1 cost, or yeah, VLAN 1 cost. Now let me change the cost to 40. The cost has been changed to 40. So now let me check, do show span. You can see, yes, F0/2 has changed to, the cost has changed to 40. Okay, now it is the root. After some time you will see something else. Okay, maybe after some time you will see something else. I'll let you shoot. Okay, so now again the next command, say, now not the next command, now you can see the cost is 40. Okay, it will take some time. It will take some time because say it has to go through the listening or the learning and then come to the forwarding. So now after some time, again let me show it to you. Yes, now F0/2 has become the blocked port. It has become the blocked port because the cost is 40. And to reach the root switch, what is the cost here? 38 is the cost. Clear? Okay, so let me show. So this has become the blocked port. Okay, now this F0/1 has become the root port. Okay, so if you check F0/1, you can see F0/1 has become the root port. Okay, now previously we had this one as the block port, this as the block port. Now this will become the designated port. Okay, so here we'll take S2 and we'll execute the command show spanning f-entry. Okay, so F0/2 has become the designated port. So this is how you will customize. Okay, again one more thing, if at all, so now the path cost here is 40. Okay, here the path cost is 19, here the path cost is 19. Okay, now so this is having, say this is having the priority, everyone is having the same priority, 32,768. Okay, now here this switch 1 is having the least MAC address, and that is why S1 is the root switch. Okay, so S1 is having the least MAC address. Okay, and S2 is having, S3 is having much, say comparing with S2 and S3, S3 is having the least MAC address. That one we have previously checked it, right? Any doubt in that?
No.
Clear? Okay, now so this is the case. So S1 is having the priority, suppose 32,768, and let me just write it down. What is the MAC address here? Okay, S1, the MAC address is 00. Okay, So the MAC address is 0007 EC31 4DBC. This is the switch ID of S1. Okay, now let me check the switch ID of S2 also. So now switch ID of S2. So here also, yes, the bridge ID. Okay, so the MAC address is this one. So the priority is 32,768 only. Now this is the MAC address. Okay, so let me write it down. Switch 2. So switch 2 has a MAC address. Sorry, switch 2 has the priority 32768 and the MAC address is 00D0 00D0, and I'm not writing the rest. Okay, now what about S3? S3 is having the MAC address 0008. Okay, 000A. So here S3 is having the priority 32,768 and 0008. Clear, guys? Now, so now in this condition, S1 is having the least MAC address, and so S1 has become the root switch. Now let me tell you how to customize the root switch. So to customize the root switch, what we are going to do? We can't change the MAC address, so we'll be changing the priority. Suppose that S2 needs to become the root switch. So what we will do is that we will change the priority of S2. We'll change the priority of S2 to 0. Shall we change it?
Yes.
Okay. So now, so S2 I'm going to change the priority. So let me change the priority. The command is spanning-tree VLAN 1 priority. Suppose I am changing the priority to 0. Okay, I changed the priority to 0. Okay, now having changed the priority to 0, this switch 2 should become the root switch. So do show span. So you can see switch 2 has become the root switch. Clear, guys? Any doubts, Sajin? Yes, because say already it knows about the root switch. Previously the root switch is having the priority 32,768. Now the priority has changed in this switch. So this switch knows itself is the root switch now. Clear? Okay. Now, so what happens? Let me tell you. So S2 has become the root switch. So both the interface of the root switch will become the designated port. Okay. Just a moment, guys. Okay, guys. So both the interfaces of the root switch will become the designated port. Okay. Now, so this will be the root port. For S1, it can go like this with a path cost of 19, or the path cost will be 40 plus 19, which will be 59. Okay, so this time F0/2 will become the root port. Clear? Okay, and here also this time, here also this will become the root port. F0/1 will become the root port. Getting it? Okay, now so we have found out the designated port for this link as well as this link. Now one more link remains. We have to find out the designated port for this third link. To find out the designated port, let me tell you. So going via this path, you have the path cost 19. Going via this path also, the path cost is 19. So the path cost has become a tie. Then the second thing will be checked. What is the second thing? Least sender switch ID. So the senders are S1 and S3 here. Who is having the least switch ID?
S2.
No, I mean among S1 and S3. Among S1 and S3, S1 is having the least switch ID because of the MAC address 0007. and so that path will be taken, and F0/1 will be considered as the designated port, and so this will become the blocked port. Clear? So this is what has happened now. I suppose you do not have any doubts.
So can you show me the command for changing the path cost?
It's not the path cost, it's the port cost that we are changing. Okay, so to change the port cost, the command is this one. Do show what is it? History. Okay, we'll go to the interface and we'll mention the command spanning-tree Vlan 1, then the cost. We'll mention
So
the
if you are
cost.
changing cost for the VLAN, the interface which are connected to the virtual LAN will all for all the cost will be 40 minutes.
Have we talked about VLAN now? No. Okay, then we'll talk about it later. Okay.
I was thinking that we should give the cost value in that interface itself.
In this interface itself. Okay, so and the interface, we haven't discussed any VLAN now. Okay, later we'll discuss about the VLAN. Okay, at that time you can ask the question. Okay. And remind me. Okay, yes.
Priority is given interface.
No, priority is given for the entire switch. So we'll be going to the config mode of the switch and we'll be giving it. Okay. Jaswant? Yeah, after going you can close that door.
Ah, yeah, you can definitely close it.
Yes, guys. Okay. Now let me tell you. So this is how you customize it. Okay. Now we are going to study types of spanning tree. Spanning tree types. So I'll be just telling the names of some. We'll be telling you later about those. Okay. First is called common spanning tree, CST. It's called common spanning tree. That's what we have discussed. Common spanning tree. Okay. Now the second thing is called Rstp. It's called Rstp, a rapid spanning tree. A rapid spanning tree. A rapid spanning tree protocol, Rstp. Rapid spanning tree protocol. Okay. So let me tell you about Rstp. So CST you will not understand now. Maybe later I'll tell you. Okay. So Rstp here, rapid spanning tree. Okay. So now what happens is that for spanning tree to run, so here we got some timers for the spanning tree, right? We have discussed about the timers. Okay, we have blocking state which will be there for 20 seconds. We have listening state which will be there for 15 seconds. We have learning state which will be there for another 15 seconds. Okay, so it will take some time for the spanning tree to run. Totally it may take 50 seconds. It may take 50 seconds for this to run. Okay, so now we are going to implement spanning tree, rapid spanning tree. So rapid spanning tree will run more faster. They'll run more faster. Okay, so that's why it's called rapid spanning tree. So to implement the rapid spanning tree, the command is we'll go to config mode where we'll mention spanning-tree mode rapid-pvst. This is the command to implement our Rstp. Spanning-tree mode rapid-pvst. Okay. Now okay. So now let me implement that in all the switches here. So now again, okay, so if you have implemented that rapid spanning tree and do show span or do show spanning tree, you can see now we are implementing spanning tree enabled protocol RSTP. The protocol has changed. Okay, and in RSTP, let me tell you, so here RSTP, you got some timers or RSTP state. Let me tell you, RSTP states. So the first state, previously it was blocking state. Now you do not have blocking state, instead you have discarding state. You do not have blocking state, but instead you have discarding state. And the second you have, so previously it was listening state, you do not have listening state, instead you have only learning state. You only have learning state. Okay, and the third one, it is the forwarding state. It's the forwarding state. So discarding, learning and forwarding. These are the RSTP states. Okay, now you got some RSTP port roles. RSTP port roles. You know some port role. The first port role, root port. Root port, you already know it, right? Okay. Root port, you already know it. Now the second one, designated port, that also you know it. Designated port. In addition to these two, you have some more. Okay, so the third one is called alternate port. Alternate port. Alternate port. Okay, and you have backup port as well. Backup port. Okay, so if at all, suppose this is the root switch. Okay, so these two are the designated port, this is the root port, and this is the root port, this is the designated, and this is the blocked port. So if at all the root port fails, let me tell you, if at all the root port fails, say the alternate port is already selected, which acts as the backup for the root port. If at all something happens to a root port, the alternate port will be made as the root port backup, or it will be made as the root port. Clear? Okay. Now, so alternate port will act as the backup for the root port. Now, backup port is the backup of designated port. If at all the designated port fails, they have already found out the backup port. They'll make the backup port on. So that's how they'll make it, or they'll be rapid. That's how it is, rapid spanning tree. Clear? Okay. So these are the RSTP port rules, and this is the RSTP. Okay, so we have been discussing about STP types, and first we have discussed CST, common spanning tree, and second RSTP, and the third one is called PVST. It's called per Vlan spanning tree. Per Vlan. We haven't studied the concept of Vlan. When after we study the concept of Vlan, I will be telling you what is this PVST. Remind me, guys. Okay, so if at all, so you can write it in the back side of your notebook. PVST. Okay, now the fourth one, it's MST, multiple spanning tree. So you can write these also. CST, PVST and MST will be discussed later when we discuss afterwards. Okay, when we have discussed the VLAN concept, I'll be teaching you CST, PVST and MST theoretically what it is. Okay, now so these are the spanning tree types. Okay, any doubt? I suppose now you have understood why spanning tree is used and how spanning tree works. Okay. Now we'll move to the next topic called VLAN. Now we'll move to a topic called VLAN. Okay, so you can write the heading VLAN. VLAN means virtual LAN or virtual local area network. Virtual local area network. Okay, now so before telling you the VLAN, let me tell you, suppose you got some computers here. You got some computers, or say again 2 more computers. Yes, you got a switch here. Okay, these computers are connected to the switch, and maybe that this switch is connected to the router also. It's connected to the router. Okay, if this is the topology, now if at all a broadcast is sent, it will be sent to all these interfaces by default, right? Because everyone, all the interface of a switch belongs to the same broadcast domain. I've taught you that, right? Okay, so I told you by default everyone belongs to the same broadcast domain. Or you can say you have a local area network here. You have a local area network. Or you have a LAN. You have a single LAN here. Okay. Or you have a single broadcast domain here. Okay. Now what I'm going to do is, okay, suppose these are students. These are students. Suppose Rakhavendra, Rekhu, right? Okay, so Rekhu. Yesterday I forgot about you. Okay, now so we have Deva, we have Vaman, we have Susmit, we have Sajin, we have Akash, right? No, Ashwin. Okay, so Ashwin, Akash is another student. Okay, now so we have one more guy, Anish. Okay, everyone is there. Now by default everyone is the part of CCNA 530 batch. CCNA 530 batch. Okay, so if at all I lecture something, I'll be, so this is, consider this myself. If at all I lecture something, say this will be lecture to everyone. This will be lecture to everyone. Okay, now suppose okay, we have Anish and Ashwin who has joined for CCNP class. Now suppose that I am managing 2 classes at a time. I'm managing 2 classes at a time. Okay, so these are CCNA students and these are CCNP students. So what have I done? Say here, so we were having a single class. A single classroom consisted of multiple students. Now the single class itself exists, but inside the classroom I have created kind of groupism, right? So here one group is there, another group is there. Okay, so if at all I am teaching CCNP, say if at all I am teaching CCNP, that will be only to Anish and Ashwin. Clear? So if at all a broadcast is sent, it will be sent to Anish and Ashwin only, because they belong to the same broadcast domain or same, say, category or same network, you can say, or same broadcast domain. And the others belong to another broadcast domain. So what I have done is that I have created two broadcast domains here. Previously it was a single broadcast domain. Now I have created one more broadcast domain and I have made Anish and Ashwin participate in that broadcast domain. So now suppose somebody is seeing it from the outside. Somebody is seeing from the outside. So they do not know we have two classes running here. Right? So Anish and Ashwin are sitting here and the rest of the guys are sitting here. So whoever is looking from the outside thinks that only one classroom exists. Getting it? Similarly, what happens is that, say suppose you got a group of computers here. Okay, so by default everyone belongs to the same broadcast domain, and that broadcast domain is called Vlan 1. There exists a single broadcast domain by default, and that is Vlan 1. So everyone is participating in Vlan 1. Okay, now everyone was in Vlan 1, but now that I have created another Vlan 10. I have created another Vlan 10. Okay, I have created another VLAN, and suppose these three students or these three computers, they are in VLAN 10. I have moved them into VLAN 10. And these three, let it be in VLAN 1 itself. VLAN 1. So what did I do here? I have created multiple broadcast domains. Okay, and each broadcast domain is called a VLAN. Okay, so what I have done is I have virtually divided. So I told you whoever is sitting or whoever is seeing outside does not know about this grouping. They will think that everyone belongs to the same broadcast domain or same VLAN, and that is why it's called VLAN, virtual LAN. Okay, I have virtually separated everyone. Clear? Okay, so if a broadcast is sent from this machine, the first machine, it will be sent to the second and the third only. Okay, now if at all a broadcast is sent by this machine, it will be sent to the machines in the same VLAN. Clear, guys? Okay, so VLAN means we are creating, so the concept of creating broadcast domains in the switch. So previously we had routers. Okay, from the in the router we actually used to differentiate different networks. Now from the switch itself you can say divide it. Okay, means in the layer 2 itself you can divide it. Okay, so that is called VLAN concept. I suppose you have understood, right? Okay, so now let me show it to you. Suppose that I am taking a switch and suppose I am taking some computers here. Okay, now let me connect it. Suppose FA 0/1, 0/2 and 0/3 and 0/4, 5 and 6. Okay, 4, 5 and 6. Okay, and here 1, 2 and 3. Okay, so here if I give an IP, suppose let me give an IP here for everyone. Suppose 10.0.0.1. okay, /20, say /8, let it be /8 itself for now, and here let it be 10.0.0.2. okay, /8, and let this be 10.0.0.3 /8, and let it be 10.0.0.4 and let it be 10.0.0.5 and let this be 10.0.0.6. okay, Now, so everyone will communicate with each other. This machine being 10.0.0.1 will communicate to .2, .3, .4, .5 and .6 because everyone is in a single broadcast domain or everyone is in a single VLAN. Let me show it to you here. So let me take the switch here and let me show it to you. The command is show Vlan Brief. This is the command, show Vlan Brief. So using this command you can see, so you got the VLANs. VLAN 1 is there, VLAN 1 and all the interface F0/1 2 3 4 5 6 7 8 say 9 10 11 12 13 14 15 16, so everyone, all the interface participates in VLAN 1. And you got some other VLANs also, 1002, 1003, 1004 and 1005, which are also default VLANs. For now we will not be considering that because we are going with the Ethernet only. Okay, for Ethernet the default VLAN is VLAN 1. Okay, so now you can see all the interfaces are participating in VLAN 1 and so everyone will communicate with each other. Okay, so if I test it, say suppose I'm pinging to the computer, say 10.0.0 suppose 2, I'm getting the reply, right? Say then 10.0.0.3 getting the reply, 10.0.0.4 getting the reply, 5 getting the reply and 6 also I'm getting the reply. Okay, now let me create another VLAN. Let me create another VLAN. So I'm gonna create another VLAN using this command. We'll go to the config mode. We'll go to the config mode. Then we'll mention the command VLAN, then the VLAN ID. We can give VLAN. Suppose I'm giving VLAN 100. I'm creating VLAN 100. So you can see we are moved into the VLAN. Config-VLAN. Okay, I have created VLAN 100, or suppose, yeah, instead of VLAN 10, I have created VLAN 100 now. Okay, then if at all you want, you can give the name. Suppose name, suppose it would be technical. Let it be technical. Just giving the name. Okay, technical. Okay, so we'll be creating. So in the production, you will be finding different VLAN, different departments, different VLAN you will find. So this is the technical department. Okay, so now you got the, now yes.
Is there a limit for the VLAN number?
Yes, exactly, you can see it. VLAN 1 to 4094. Okay, but we'll be configuring up to 2 to 1001. Okay, because say VLAN 1 is default. VLAN 1 is default VLAN. Okay, now VLAN 2 to 1001 you can configure. These are the normal VLAN. These are the normal VLAN. 1002 to 1005. These are also reserved. Okay, default VLAN for some other say network standards. Okay, so like default VLANs. Now 1006 to 4094, these are called extended VLANs, which we'll not be discussing now. It is in scope of CCNP. Okay, so 1006 to 4094, these are called extended VLAN. Okay, yes. Okay, now want to write it? Okay. Okay, yes. Now, so now after giving the name we can exit. After exiting, the VLAN will be created. Okay, VLAN will be created in a file called vlan.dat. The file will be created, and in this file say the VLAN information will be there. Okay, now so if you want to check, if you want to view it, so do so. Yes, having doubt?
Created in a file called
vlan.dat, vlan.dat. Okay, yes. Now, so here you can see, now let me show it to you. Do show Vlan Brief. Okay, so using this command, now you can see VLAN 1 is already there and all the interfaces are participating in VLAN 1 only. Now, but VLAN 100 is being created. VLAN 100, we have created the VLAN 100, but no interface are participating in VLAN 100. If you want to make, say, or if you want the interface to participate in VLAN 100, you need to go to that interface and mention some commands. Okay, so you will go, suppose that we want to make these three interfaces participate in VLAN 100, F0/4, 5 and 6. If you want to make these interfaces participate in the VLAN, we'll go to those three interfaces. The command is, we'll go to those three interfaces together and we'll configure them together. Okay, so we'll go to the range of interfaces. Interface range fast Ethernet 0/1-3, sorry, 4-6, 4-6, because 0/4, 5, 6, we need to move them to VLAN 100. Okay, so we have moved into those range of interfaces. Config if range, where we'll be giving the command like this: switch port mode access, which we'll study later, and switch port access VLAN 100. This is the command. Okay, this command we'll study later. Switch port mode access. Okay, now we have made it the access VLAN 100. That means we are making these interface participate in VLAN 100. Clear? Okay. Now let me exit. Okay. Okay. Now we'll mention the command do show Vlan Brief, and you can see technical VLAN is there, and you can see FastNet 4, 5 and 6 are part of VLAN 100. Clear? Okay, so that means now that this is in a different broadcast domain, these machines will communicate each other, but this machine will not communicate to the VLAN 1 machines. Shall we try it out?
Yes.
Okay, so previously we were able to ping. So ping to 10.0.0.6, it was successful. Now if we ping to 10.0.0.6, it's not successful. Clear? Because it does not belong to the same VLAN. Okay. Yes. So if you ping to 10.0.0.5, that is not that is also not accessible. Okay. So if you ping to again 10.0.0.4, it's also not accessible. But if you ping to 10.0.0.3, what happens? It will ping. It will ping and you are getting the reply because this is in a same broadcast domain or same VLAN. Clear? Okay. Now, so this is how you will create the VLANs. Okay. Now let me tell you here. Now let me tell you switch interface state. Sorry, switch interface modes. Okay, you can write the heading switch interface mode. Switch interface modes. Okay, so the first mode is the access mode. It's called access mode. Access mode. Okay, so let me tell you what is access mode. I have given the command like this. I have gone to an interface and have defined switch port mode access. It means I have made this interface work as access mode. Okay, so the access mode means it will participate only in a single VLAN. It will participate only in a single VLAN. Okay, so these interfaces now will participate only in a single VLAN, and by default, if you give switch port mode access, it will participate in VLAN 1 only. Okay, and now you have changed it to from VLAN 1 to VLAN 100. Okay, so that means if you change it to access mode, that means it belongs to only one VLAN. Okay, and by default it will be VLAN 1. So that means it will pass VLAN 1 information. It will pass VLAN 1 information. Getting it? Okay. Now you got the next mode, which is called trunk mode. It's called trunk mode. It's called trunk mode. Trunk mode. Okay, let me tell you. So trunk mode means it participates in multiple VLAN. It participates in multiple VLAN. And it passes all those VLAN information. It passes all those VLAN information. Let me tell you an example where the trunk is used. Okay, pass all VLAN information. Okay, suppose you are having two switches S1. Okay, so let me draw it bigger. S1 and this is S2. Okay, now suppose you have F0/1. So you got two here, F0/1 and F0/2. Okay, so here you got two machines. Here also you got two machines, F0/1 and here F0/2. Okay, now you got another two machines here, F0/ say suppose 4 and F0/5 suppose. Okay, here also the same thing, F0/4 sorry 0/4 and F0/5. Okay, now suppose these two are in a VLAN. These two interfaces are in VLAN 1. VLAN 1. These two interfaces also will be in VLAN 1. These two interfaces, suppose this is in VLAN 100. Okay, and these two interfaces in VLAN 100. Okay, so obviously you know this machine will communicate to this machine. Okay, and these two machines will also communicate with each other. Okay, similarly these two will also communicate with each other, and these two will also communicate with each other. Clear? Okay, now what about these two? Suppose I want this machine, the first machine, to communicate to the second machine. If I want them, suppose I am connecting this interface. Suppose that I am connecting this interface switch to switch, F0/10 to F0/10. If I connect it, okay, so whether this communication machine 1 to 2 will communicate or not? Will not communicate. Why? Because which is in different VLAN, which all interfaces are in different VLAN. What you said is right. Yes guys, so if you try to ping from machine 1 to machine 2, the communication will not happen, because by default I told you, if you connect these switches, it will participate in VLAN 1 by default. By default it will be in VLAN 1. VLAN 1. So both will participate in VLAN 1. So if he is sending, this guy is sending a broadcast, it will be sent only to this interface. Now what about these two? This third and fourth machine, will they communicate? Yes or no? Yes. Because if at all he is sending a broadcast, it will be sent here, it will also be sent through this interface, and it will be sent to here as well. So they will communicate. Okay, so VLAN one-to-one communication will happen here. Okay, but what about VLAN 100 to 100 communication? Here, in order for this to happen, you will have to connect another link. You will have to connect another link. Suppose F0/11, F0/11. Okay, that can be a solution. But what if you have another VLAN, VLAN 200, and again VLAN 200? Again, you will have to connect another link here. Again, if you have VLAN 300, VLAN 300. Again, you will have to connect another link. So you will have to connect multiple links, which will be like again a complex. So now what we will do is that we will make this interface in the sense, sorry, this VLAN 100. This F0/10 interface, we'll make this interface as trunk interface. We'll make this as trunk interface or trunk mode, so that this trunk interface will say pass all the VLAN information. It means if at all the broadcast is sent, this VLAN 100 information will be passed through the trunk interface. If at all the broadcast is sent through VLAN 1, so VLAN 1, this machine sends a broadcast, it will also be sent through the trunk interface, because trunk interface passes all the VLAN information. Clear? Okay, so to make the interface as a trunk, the command is we'll go to, we'll go to the interface and we'll mention switch port mode trunk. That's the command. Okay, so let me show it to you here. Suppose that we got another switch. Okay, suppose that we got another switch here. Say, let me take it. You got another switch, and let me connect it. Suppose F0/10 to F0/10. Okay, now, so by default, it will participate in VLAN 1. Okay, you already know it. So, yes, if you go to the switch and execute the command, show Vlan Brief, you can see F0/10 is in VLAN 1. Clear? Okay. Now, if at all you want to make it as a trunk interface, you will go to the interface FA 0/10. It's 10. Okay. Then you will mention the command switch port mode trunk. This is the command. Clear? So when you do it in the real switches, you will have to give one more command. Okay, before executing this command, you will have to give one more command. The command is like this: switch port trunk encapsulation .1q. You will have to give this command as well. But here in the switch, it will not accept. But in this packet tracer, it will not accept. When you do it in the real switch, you will have to give this command: switch port trunk encapsulation .1q, which I'll tell you later what it is. Okay, so we'll give this command, and then we'll give the command switch port mode trunk. Clear? Okay. So, having configured it as a trunk port, okay. So let me again execute the command do show Vlan Brief. Okay, previously we have seen F0/10 here. F0/10 was participating in VLAN 1. Now after you make it as a trunk, can you see the interface F0/10 anywhere? No, because it is a trunk interface, and to view the trunk interface you have a separate command. The command is do show interfaces trunk. Do show interface as trunk. So if you check this command, let me show it to you here. You can see fh0/10. Okay, and it is mode on. That means we have manually made it as a trunk. Okay, and you can see VLANs allowed on the link 1 to 1005, and VLAN allowed and active in the management domain. VLAN 1 and 100. It means it will pass both VLAN 1 information and VLAN 100 information. Clear? Okay. Now, if at all you have another VLAN, say suppose I am creating another VLAN, VLAN 200, VLAN 200. Okay, and that VLAN information will also be passed in the trunk interface. Do show interfaces trunk. You can see this also will be passing in the through the trunk interface. So all the VLAN information will be by default will be passing through the trunk interface. Clear? Now you can customize the trunk interface again. You can customize the trunk interface. If at all you do not want all the VLAN to participate, again you can customize it. You will go into the trunk interface. So interface, say fast Ethernet 0/10. We went into the interface. Then we can mention something like this: switch port trunk allowed VLAN. Then say suppose you can add any VLAN, or if you want you can remove the VLAN, or you can do anything. Okay, so let me remove VLAN 200.
Or you can set range also.
Range also you can set. Okay, so here 200. So it is now allowed, and now you need to remove the VLAN. This is how you will remove the VLAN. Okay, sorry. VLAN is not needed, 200. Remove 200. Okay, so this is how you will remove switch port trunk allowed VLAN, remove 200. So now if you execute the command do show interfaces trunk, you can see 200 is not allowed. VLAN allowed on the trunk from 1 to 199 and 201 to 1005. That means VLAN 200 has been removed, and VLAN 200 will not be passing through this trunk link. Clear? Any doubts? Okay. So this is how you will customize the trunk. 1 to 199 means so we have just excluded the 200. So excluding the 200, rest of the thing will be allowed. Getting it? Okay. Now the next thing. So this is how we customized it. Okay. Now let me tell you. So here you have got the third one here. Where is it? You got the third mode, which is called dynamic mode. It's called dynamic mode. Dynamic mode. Okay, now let me tell you about dynamic mode. So here from this switch 3 to switch 4 connection, to switch 3's F0/10, we have made it as trunk interface. Did we tell anything in F0/10 of switch 4? No. We didn't mention anything in F0/10 of switch 4. So if this interface is in dynamic mode, what happens is that it automatically changes. It will automatically change to either trunk, or it will automatically change to access. Okay, so now if you check, it might have automatically gone to the trunk, because in the other end we have configured the trunk. So this end will automatically become the trunk. Clear? Shall we check it? Okay, so here in switch 3's F0/10, let me check first. Okay, in switch 3's F0/10, if you check do show interfaces trunk, you can see it is F0/10 is trunk and the mode is on. Means we have manually made it as trunk. Okay, now if you check this one, switch 4, show interfaces trunk, you can see F0/10 has become the trunk interface, And how it became the trunk? It has automatically changed. It has automatically changed itself to trunk. So that is why mode is auto. Clear? Again, one more thing. So here we'll go back to switch 3 and we'll execute the command show interfaces faster than a 0/10 switch port. This is the command, show interface faster than a 0/10 switch port. If you execute this command, you can see F0/10 details. F0/10 administrative mode is trunk and operational mode is also trunk. It means we have administered, we have configured it as trunk and it is working as trunk. Clear? Okay. Now here when you go to switch 4 and check show interfaces faster than a 0/10 switch port. Okay, if you give this command, let me show it to you. Here administrative mode is dynamic auto and operational mode is trunk. It means it is administered or it is configured with dynamic. Okay, it is configured with dynamic mode and it is operating in trunk mode. Clear? Any doubts? Okay, so one more thing to add, the dynamic itself. So where is it? Yes. So in the dynamic mode itself you got two types. Okay, dynamic desirable and dynamic auto. Dynamic desirable and dynamic auto. Just for understanding, I have told you. Okay. Auto. AUTO. Any doubts? It has automatic. Say some switches will be having its interfaces in dynamic auto. Okay, some switches will be having its interfaces default. It will be there in dynamic auto, or some switches will be having dynamic desirable by default. Okay, it means, okay, let me tell you. So here dynamic auto. Okay, so here I suppose they might be default, they will be having dynamic auto here. Here also they'll have dynamic auto. Okay, by default it might be. So that's why I say the switches will be having these interfaces will by default will be in dynamic auto. Not all the switch interface. Some models will be having dynamic auto. Some models will be having dynamic desirable. Okay, so when they connect to each other, if it's dynamic desirable, if both are dynamic desirable, let me tell you what happens. They will automatically form the trunk link. You don't have to mention it manually. They'll automatically form the trunk link. Clear? So by default it might be either dynamic auto or it might be dynamic desirable. Clear? Okay. Now, so these are the switch interface modes. Okay. Now we'll go to some other thing as well. Okay. Do you need a break? Yes? Okay, then we'll give you a break. Okay. I've been taking it continuously and I didn't remember the time as well. Okay, so we'll give a break till say 6:51 p.m. Okay. Yep. Okay, so now we'll discuss DTP, which is called Dynamic Trunking Protocol. Dynamic Trunking Protocol. Okay. Yes. So let me tell you what is this dynamic trunking protocol. Okay. Suppose you got two switches here. You got two switches. So here you got VLAN. Yes, VLAN 1. Okay. And this also VLAN 1. And this is VLAN 100. And this is VLAN 100. So now when the VLAN 100 is sending an information through the trunk link, when the VLAN 100 is sending the information through the trunk link, what the trunk link will do is that it will mark the frame. Suppose this is the frame, it will mark it as VLAN 100, so that when switch 2 receives it, he knows it is VLAN 100 information, and then will be forwarding it to all the VLAN 100 interfaces. So the dynamic trunking protocols, or DTP, will help you to add this VLAN information while passing it through the trunk link. Clear? Okay, so now you got two protocols here, dynamic trunking protocols. The first one is ISL. It is ISL, inter-switch link. Inter-switch link. And the second one is .1q. .1q, or it's called IEEE 802.1q. Okay, .1q or IEEE 802.1q. Okay, so now inter-switch link, it is a Cisco proprietary protocol. Cisco proprietary protocol. Cisco proprietary protocol. Okay, now what ISL will do is that, so if this is the frame, he will encapsulate it with a header, ISL header, and an ISL trailer. He will encapsulate with an ISL header and an ISL trailer. The header contains 26 bytes. The header contains 26 bytes, of which 15 bits. 15 bits says it's a VLAN ID. It tells about VLAN ID. Getting it? So this 15 bit says it is VLAN 100. Clear? Okay. Now you got .1q as well. You got .1q. So .1q says, or what .1q will do is that, if at all you are passing a VLAN information through the trunk link, okay, so it will add certain tag. It will add certain tag to the frame. Okay, and this tag contains 4 bytes. This tag is of 4 bytes in size. 4 bytes or 32 bits. 4 bytes or 32 bits, of which 12 bit is reserved for VLAN ID. 12 bit is reserved for VLAN ID. Getting it? Okay. So let me just tell you. So here, if it is a frame, suppose this is the packet. This is the packet. You know the packet structure, right? So the packet will be having network header, and inside you will have the segment and all. Okay. So this is the, say, 8.0, say, or Ethernet header. Okay, L2 header. Okay, in between L2 header and the packet, they will add the tag, and the tag will have many fields. The tag will have many fields. One field is called TPID. It's called TPID. Okay, tag protocol identifier, which is now it's unnecessary. Okay, so now TPID, it consists of 3 bits field. It consists of 3 bits field, which is called class of service. It's called class of service. Then it have one more bit. Okay, say I forgot that one. Okay, leave it. Now this is not really necessary for you. Okay, now you got, at last you got, say, VLAN ID 12 bit. VLAN ID is 12 bit. Clear? Okay, so this is how. So this VLAN ID says it belongs to VLAN 100 or VLAN 20 or VLAN 200 or whatever it is. Clear, guys? Okay. Now In native VLAN, suppose you got a switch. You got a switch here. And you got another switch. Okay, suppose you got a machine participating in VLAN 100. Okay, another machine participating in VLAN 100. Okay, now you got machine in VLAN 200, machine in VLAN 200. Okay, machine in VLAN 300, machine in VLAN 400. Okay, so now again machine in VLAN 300 and machine in VLAN 400 and machine in VLAN 1. VLAN 1. So if at all it is 802.trunk, it is implemented. Okay, let me tell you, if at all say VLAN 200 is sending something, the frame will be tagged. The frame will be tagged and the tag will have VLAN 200 in the VLAN ID section. If it is VLAN 100, then it will have the tag as VLAN 100. If it is VLAN 300, it will have the tag VLAN 300. If it is VLAN 400, it will have the tag VLAN 400. It will be having the tags. Okay, now you got a concept called you got a concept called native VLAN. You got a concept called native VLAN. Okay, so native VLAN is by default VLAN 1. Native VLAN is by default VLAN 1. If VLAN 1 is the native VLAN, then that means if at all some VLAN 1 information is sent through 802.1q trunk link. If the VLAN or the native VLAN information is sent through the 802.1q trunk link, they will not tag it. They will not tag it. Okay, so except the native VLAN, all the VLANs will get tagged. Getting it? So you can see here, let me show it to you. Show interface trunk. You can see the encapsulation is 802.1q and the native VLAN is VLAN 1. Clear? If at all you want to change the native VLAN, you can change it like this. You can go to the interface fastnet 0/10 and you can configure the native VLAN like this: switch port trunk native VLAN, suppose VLAN 100. This is how you will change the native VLAN. Clear, guys? Okay. If you change it, then do so interfaces trunk will show the native VLAN as VLAN 100. Clear? Okay. So this is the command. After changing, you can see the native VLAN is changed to VLAN 100. Any doubts? Clear? Yes, please.
So to change the native VLAN, we went to the particular interface F0/2. So by default, in VLAN 100 there will be multiple interfaces.
In VLAN 100 there will be multiple interfaces.
The range of from F0/10 to 15.
Okay.
So only the 10 only will become the native VLAN, or the entire?
No. So this is the trunk interface. Okay. So if you are telling that F0/1 to 15 is participating in VLAN 100, those are access interface. Those are separate. Clear? Okay. Now this native VLAN is specific to only this interface alone. If you have some more interfaces which are in trunk, that will not be affected here. Okay, you are changing the native VLAN only in this interface F0/10. Okay, yes. Now, so this is the, and let me again tell you. So here you can see the encapsulation as 802.1q. If at all you want to change the encapsulation, the command is switch port trunk encapsulation. You can type ISL. This is the command to change the encapsulation or the DTP, dynamic trunking protocol, to ISL. Okay, or if at all, if it is ISL, if at all you want to change it to .1q, you can type .1q, switch port trunk encapsulation .1q. So this is the command that I told you, we'll discuss later. Got it? So again, so this command will not be accepted in the packet tracer, but in the real switch it will be accepted. Clear? Okay. Now let me tell you, you got one more thing here. Okay. The third one is called auto. It's called auto. It's not a protocol here. It is an option. It's an option. So here it can be either, the encapsulation can be either ISL or .1q. So here also it can be either ISL or .1q, or it can be auto as well. It can be auto. Auto means it will, if ISL is set here, it will change it to ISL. Automatically it will get changed to ISL. If .1q is set here, automatically it will get changed to .1q. So that is auto. Getting it? Okay. Now let me tell you one thing. If this is auto, the encapsulation type or the DTP is auto, you will not be able to configure the trunk manually. You will not be able to configure the trunk manually. So it should be either .1q or ISL, and that is why I told you you can configure .1q. I mentioned while configuring trunk, I told you that you need to mention the command, this command. Okay, so export trunk encapsulation .1q, because by default there are chances that it will be auto. If it is auto, then they will not become the trunk manually. It will throw an error. Clear? Any doubts? Okay. So this is dynamic trunking protocol, DTP. Okay. Yes. Now we'll study one more thing. Okay. Yes, we'll study something called VTP. We'll study something called VTP. Vlan trunking protocol. Vlan trunking protocol. VTP. Vlan trunking protocol. Okay. So now let me tell you. Suppose in this diagram, suppose you got multiple switches here. You got multiple switches here. So we have created VLAN 100 and we have created VLAN 200 in both these switches. VLAN, I mean not in both the switches, in this switch. In switch 3 we have created VLAN 100 and VLAN 200. So again we need to create VLAN 100 and VLAN 200 here. VLAN 100, VLAN 200, VLAN 100, VLAN 200, again VLAN 100, VLAN 200. So if you have multiple switches, creating that VLAN and managing the VLAN or deleting and renaming these VLANs and all, so you have to do this in all the single switches. So in each and every switch you have to configure it. You need to create the VLAN 200. Okay, so to make it easy, we will configure VTP, VLAN trunking protocol. So in VLAN trunking protocol, if VTP is enabled or if VTP is done, say if at all a VLAN is created in this switch, it will automatically get created in all the switches. Getting it? If a VLAN is deleted in a switch, then say all the switches also will delete this VLAN automatically. Clear? Okay. So now again let me tell you, to do the VTP configuration, two things are must. First thing is that all the switches should be a part of the same domain. Yesterday I suppose I might have taught you how to give the domain name, right? So all the switches might be, or it should be the part of the same domain. Okay. Moreover, all the switches should be connected using trunk link. All the switches must be connected using the trunk link. Clear? So all the switches should have the same domain name and they should be connected using the trunk link. So that is VTP, VLAN trunking protocol. Okay. Yes. Now the next thing, so if you implement VTP, there having doubt?
No.
Okay. So if you implement VTP, you can configure these switches as 3 parts or 3 modes. You can make them configure, or you can configure them as 3. Okay, there are 3 modes of VTP. The first mode is called server mode, VTP server mode. The second is called VTP client mode, and the third one is called VTP transparent mode. VTP transparent. So VTP server, VTP client, and VTP transparent. Okay. Server, client, and transparent. In server mode, if a switch is configured as a server mode, you can create the VLAN, you can delete the VLAN, you can modify it. Okay, so you can modify, you can create, delete, and modify the VLANs in the server mode. In the client mode, if suppose it is client mode, say you cannot create, modify, or delete any VLANs because it's in client mode. Okay, and at last you have transparent mode switch. Transparent means you can create, modify, and delete the VLANs, and these VLANs will be exclusively for them. If you create a VLAN 300, no switch will be, or so this switch will not send any messages to any other switch telling that VLAN 300 is created. Getting it? It's a kind of, you can say it's a kind of secret switch. Okay, it will maintain the secrecy. It will maintain the secrecy. Getting it? Okay, so that's what transparent switch. I suppose you have understood. Okay, now, so this is the VTP, VLAN trunking protocol. Any doubts? So
What happens in VTP client mode?
in VTP client mode, you cannot do anything. So if a VTP, nothing will happen. Okay, if a VTP server is configured with VLAN 100 or VLAN 200, then some VTP messages or VTP advertisements will be passed, and they will automatically create the VLAN. Okay, will automatically create the VLAN. Okay, so automatic VLAN creation will be possible, but manually you can't configure any VLAN inside those switches. Clear? Okay. So this is the VTP. Now let me ask you. So now switching portions tomorrow we'll complete switching. Okay, so what all portions are left is inter VLAN. So far we have been telling about the same VLAN communication or intra VLAN. Okay, so same VLAN communication, say VLAN 10 to VLAN 10 or VLAN 20 to VLAN 20. So tomorrow we'll talk about how VLAN 10 can communicate to VLAN 20. Okay, then so inter VLAN is there. Okay, so that itself you got 2 types. You will study both. Okay, that requires 45 minutes maybe. Okay, then we have something called, say, port security, which is a security topic in switching. Port security. Okay, then tomorrow we'll be studying after that ether channel. Ether channel. ETHER, ether channel. Then we'll be going with some small configurations. Okay, maybe spanning tree related configurations, and that's the end of switching. Clear? So then shall we wind up the class for today? Okay. Yes. Thank you guys. So we'll see tomorrow.
So we'll configure client, server, and the.
No, Vtp configuration is not there for you. Okay. Yes, somebody has pinged it. So Rakesh, I really didn't see your message. Rakesh and Selva, I didn't see your messages because. So let me pause recording.